today we're going to do all of section 3.3. We are going to start with some things that are on that paper that I just gave you. So I've got this little chart on the front board here. We're going to try to figure out the probability of people in this room of being a brown hair, blue-eyed individual. Okay, so what I need everybody to do first is to come to the front of the room and just put a tally mark in the one box that you feel like best fits your hair and eye color. Okay, and it's up to you if you want to go with like natural hair color, dye. I knew that was me because I'm like dark hair, but it's light. Like just you pick. Okay, pick one, put it in the box. Go. Now let's go ahead and put those totals on there. So it looks like blonde and blue, we've got 5. Green 1, brown 0, then 4, 3, 3, and then lots of zeros on the bottom. Okay, so now with that information, I want you to see if you can answer using the table the rest of the questions on that front page. You guys can work in groups on this if you want to work in groups of 2 or 3 or 4 or by yourself, that's fine. Maybe like around 10-15 minutes. Find the different probabilities from the table, and then we'll come back together and talk about them. Let's see how you did. I didn't turn them into decimals, I just left them as fractions. So it would be helpful if you didn't already on the chart to maybe put totals on the side and the bottom, and then the nice thing about the total is it should be the sum of all the rows that are totals and the sum of all the columns that are totals. So you can check it 2 ways to make sure you've accounted for everybody, because then you can use those to work backwards with then if you need to, especially when our numbers get pretty big. We had a lot of zeros in here, so that wasn't terrible. All right, so back to this then. I just reduced my fractions. For each of these. The one that really is going to be pretty applicable to our lesson today is the first one under number 3 there, where it says find the probability that you have brown hair or blue eyes. So there were 10 people in the group that had brown hair. There were 9 people in the group that had blue eyes. We can't just add those together because it's 19. That's more than the people in this room, and we can't have a probability bigger than 1. So what ends up happening when we have a lot of these tables and these like overlapping groups is that we double count people. If we're talking about the probability of somebody having brown hair or blue eyes, there's people that just have brown hair, there's people that just have blue eyes, and then there's people in the middle, like in the middle of like a Venn diagram, an intersection, people that have brown and blue that are counted in both groups, and they're double counted, they're counted twice. So if you have a table, it's easy enough, you can just add up the separate cells to get that 15. But when we talk about formulas, we're going to end up having to subtract that group that was counted twice in general when we see the word or. So if you're not figuring it out already, we saw the word and before. That means you're going to multiply your probabilities. If you're seeing the word or, you're going to be adding your probabilities now. So those are key things that you're going to look for because these problems are all going to start to be like kind of blending together a little bit. Any questions on any of these answers? Okay. So on the back then, you could maybe have done number 4 also. Don't worry about number 5. We actually already did that earlier. So not green eyes. If you have green eyes, that's just another review of complementary events. 1 minus the probability that we had. So probability of green eyes was 1/4. 1 minus that, 3/4. Brown hair was 5/8. 1 minus that, 3/8. Okay. All right. So we'll come back to these card examples in a minute. Let's just kind of talk about a couple things first. Okay. So we've already talked about independent versus dependent events. Independent events are events that do not affect one another, and dependent are events that do affect one another. When we talk about the word mutually exclusive, we're talking about groups that have potentially something in common or not. Okay, if you're mutually exclusive, you do not have anything in common. So decks of cards, okay? My aces in a deck of cards and my kings, there's no overlap. There's no ace that is also a king in the deck of cards. Things that are not mutually exclusive are where we have that overlap that we have to worry about. Like if we talk about all the hearts in a deck of cards versus all the kings, there's one that is counted in both groups, okay? So mutually exclusive is when groups have nothing in common. Okay, so real quick, you don't even have to write this down. Just what do you guys think about this first one? We're just telling if they're mutually exclusive or not. Event A is rolling a 3, event B is rolling a 4 on a die. Are those mutually exclusive? Yes or no? Do they have anything in common? Is there an overlap? No. So they are mutually exclusive events. Yes. Okay, what if I'm, let's say, out of college and I randomly grab a student? Okay, so event A is randomly selecting a male student. Event B is randomly selecting a nursing major. Are they mutually exclusive? No, why not? Why not?
Because you could have a male student who's majoring in nursing.
Yeah, there could be an intersection there. You could have somebody that's in both groups. Randomly select Jack from a deck of cards. Randomly select a red card. Yes or no? No? And we could have a red Jack. Would be the example, right? So as long as you can provide one example that falls in both events in both groups, it's not mutually exclusive. Okay, here we could have a male nursing major. All right. So the addition rule in general, and remember these formulas are on the formula sheet you guys have. This one might be worth writing down on your paper that you have. Okay. This formula will work whether or not they are mutually exclusive. It's always helpful to know that, but if they're not mutually exclusive, we have to use this. We're double counting that group that's in the middle. If they are mutually exclusive, we end up just subtracting 0, nothing that they have in common. So it doesn't harm anything to use this formula. So in general, if we want to find the probability of event A occurring or B occurring, we add the probability of A plus the probability of B minus the probability of A and B, which is the intersection of the two, anybody that's counted twice. Okay. Remember, if it's and, we're just multiplying the probabilities together. Probability of A times the probability of B. Okay. Good. All right, so back to your paper now. Let's do a couple of these together. You select a card at random from a standard deck of 52 playing cards. We're going to find the probability that the card we pick is a 4 or a king. Okay, if we see the word or, we're going to use our addition rule. So we are calculating the probability that it is a 4 plus the probability that it is a king minus the probability that it is a 4 and a king. Putting the two together. What is the probability that it's a 4? If I pull one card out. How many 4s are in a deck of cards? You know this. Yes. 4. Out of how many? How many cards do I have? 52. Don't overthink it. How many kings do I have? 4. Out of how many? 52. Are there any cards in a deck that are a 4 and a king? No. Minus 0. Which means we have mutually exclusive events if we want to name it. So I get 8 out of 52. If I add my probabilities together, which those are both divisible by 4, so 2 out of 13, and then whatever decimal that is, you could always turn it into that. Okay. Red or a face card. Okay, so using the formula, probability that it is a red plus the probability that it's a face card minus the probability that it's red and a face card. How many red cards are in a deck of cards? Half of them, 26. Perfect. All right, face cards are anything that has a face. So Jack, Queen, and King. How many of those do I have? 12 out of 52. Minus anything that's a face card and is red. So if I have 12 face cards, how many of them are going to be red? Half of them, 6. Those guys are counted in both groups. They're counted, that's 52. They're counted twice. Okay, denominators are all 52. That's easy. You just have to add and subtract your numerators. So 26 and 12 give me 38. Minus 6 gives me 32. Those are both divisible by 2. So that gives me what? 16 over 26, 8 over 13. Okay. You roll a die. Find the probability of rolling a number less than a 3 or rolling an odd number. Rolling a number less than 3 or rolling an odd number. How many numbers are less than 3 on a die? Start with that. I know you know this, guys. You do. You're just first period, and first period never talks. I get it. How many numbers are less than 3 on a die if I roll a die? Come on. We can do it. 2. Thank you, Nora. Probability of an odd number. How many odd numbers are on a die? 3. All right, minus, put them together. How many numbers on a die are less than 3 and odd? 1. Thanks, Bree. 5 minus 1, 4 out of 6. 2/3 is my probability. Okay? Questions there? Great. All right, so you guys try this one. So we're back to our blood type examples now, and we've got it all categorized. We've got the type at the top. We've got whether you're Rh positive or Rh negative on the bottom. See if you can find these 4 probabilities using this information. All right, let's see. So a couple of these you can do a few different ways, like letter B. I did it with the complements just to show you that work, but you could have done it actually really similarly to part A if you wanted to. Did you guys notice that the totals on the side and the bottom were helpful here? Okay, so if you don't have those, definitely put them in. It's going to make your life a little bit easier. You just have to remember to subtract out the intersection of whatever row and column you're looking at if one applies. Questions on the addition rule for probability? Okay, so as far as what else I have on here for you, the only other 2 slides, and I just put these on here so you guys have access to them on Polaris if you want to. This is a really nice chart, I think, that kind of summarizes a lot of the things that we've talked about so far with our probabilities. Remember, a lot of the formulas, though, you guys have that purple sheet already for it, so that's nice to have handy. And then if for some reason in Math Excel you were to see this notation instead, if they don't use the word and or, they might use the intersection symbol and the union symbol. The upside down U is the same as and the regular U is the same as for. So you might see those written. Hi, this is Miss McDonald. I'm gonna do it right now for you. You're welcome. Bye. It's calling me. All right. The rest of the period